Today I'd like to do a little demonstration and discuss the different types of sampling methods that are used pretty much all the time these days, and discuss whether or not each of them is really a random sample. When we collect a sample, we just don't want any sample. We want to have what we call a random sample. So let me give you a definition of that. If you can read this, a sample of any size is a random sample if you have selected your sample in such a way so that every member from the population has an equal chance of being selected for the sample. That's what it takes to have a random sample. So let's do an example. And I thought we'd do examples by using M&Ms. Okay? Now, there are many ways you can measure M&Ms, and one thing you can measure is their weight. At the M&Ms factories, they are always constantly checking to make sure that they have uniform weight. So how would they go about testing that? Well, one way would be to pick out randomly from a bag of M&Ms, pick out, say, keep it simple here, 8 M&Ms, and weigh them. Okay, now the question is, what's a proper way to go about picking out 8 M&Ms? Well, one way is just reach in the bag and pull off 8 M&Ms from the top. We got 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's 8 M&Ms. Okay? Now, is that a valid way? Well, not really. I can't tell you why not, but I bet an engineer or a quality management person at the M&Ms might tell you, give you some good reasons why it's possible that the M&Ms that are at the very front of the bag that are pulled out first might not be a good representation of the weight of all the others. Okay? And this type of sampling method is known as convenience sampling. Convenience sampling in general hardly ever gives you a good random sample. Remember, to be a random sample, every possible member, in other words, every possible M&M in this bag, has to have an equal chance of being chosen for the sample. Now, obviously, if I'm just picking off the top, the ones near the bottom have 0 chance of being chosen. So, convenience sampling is not a good method for sampling if you want a random sample. Okay? Let's take another type of sampling. Let's use what we call systematic sampling. So let me pour some more out here. Okay, got some M&Ms here, and if we line them all up, okay, systematic sampling says line things up in an order, and then decide we're going to take every nth M&M. For example, say we're going to take every 6th M&M. So here we go. I'm going to start here. Hopefully you can see this. 1, 2, 3, 4, 5, 6. Take this one. 1, 2, 3, 4, 5, 6. Take this one. 1, 2, 3, 4, 5, 6. Take this one. 1, 2, 3, 4, 5, 6. I got this one here. I'll go 4 together. 2, 3, 4, 5, 6. I got this one. 1, 2, 3, 4, 5, 6. I got this one. And we got 1, 2, 3, 4, 5, 6. So I'm supposed to have 8, but for right now, let's say I've got a sample of size 6. This is a common method of sampling, systematic sampling, taking every nth item. The question is, does it produce a random sample? And the answer is, no, it doesn't. Because once I put these in order here, are any of these first 5 ever going to be chosen? They have no chance of being chosen. 0 chance. Same here. 0 chance of being chosen. 0, 0, 0. As soon as I establish an order, there goes my random sample possibilities. Okay? All right. So that's not a good random sample. Let's take a third case. A third type of sampling that's often used is called stratified sampling. Now, stratified sampling, we do it in 2 steps. Our first step is to simply group the members in some way. Well, the easiest way I can think of grouping them is by the different colors. So let's do that. Let's put all the browns together here. Okay. And there may be lots of other ways we could group them. Hopefully these colors show up well. I don't know. We'll see. Okay, and I got my yellows over here. So I've got a nice segregated bunch of M&Ms, don't I? All right, so what have I got? I've got 1, 2, 3, 4, 5, oops. I'll get that green out of here. Six different groups of M&Ms. Obviously, some groups have more than others. All right, this is my first step in that stratified sampling method. After I got them grouped, then what I do, I randomly choose some number from each group. Let's say I'm going to have a sample of size 6, so I'm going to randomly choose 1 from each of my 6 groups. So I'll randomly choose this one, and I'll randomly choose this one, and this one, and this one, and obviously with these two only have 1 in it, so I've got to take this and got to take this one. Okay, the question is, did that produce for me a random sample? Once again, the answer is, well, no, it didn't, because not every M&M had an equal chance of being chosen. Since over here in the brown M&Ms there are 1, 2, 3, 4, 5, 6, 7, 8, each brown M&M had a 1 out of 8 chances of being chosen. Over here in the yellow there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So every one of these had a 1 out of 10 chance of being chosen. And if we want to go one step further for the red and the blue, well, they had a 100% chance of being chosen because those were the only ones in the group. So once again, not a random sample because they didn't have an equal chance of being chosen. Okay, last type of example we're going to look at of randoming method, a sampling method, is what's called the cluster method. Okay, so once again, we start off the same way as we for stratify. We break it up into different groupings, and again, the easy grouping is by color. Now what I do here is identify each of these groupings with a number, say 1, 2, 3, 4, 5, 6, okay? And here's what I do for this clustering sampling method. For a cluster sampling method, I randomly pick a number from 1 to 6. Let's say I randomly pick the number 3. So 1, 2, 3. This entire group's right here becomes my sample. Is that a random sample? Well, did every M&M have an equal chance of being chosen? And the answer is yes, it did. Since there were 6 groups, and I identify I'm going to choose a number from 1 to 6, then every M&M had exactly a 1 out of 6 chances of being chosen. So we finally found a method, namely the cluster sampling method, that does provide us with a random sample.